We have been talking about the functional components of a computer. Now we are going to talk to the physical components, and we will start with this. This is a CPU, a real CPU, and we are going to take a look to the how it's structured and how the physical implementation of a CPU works. So here we have the pictures, some pictures of the CPU. This is a case, and inside the case is a silicon base, and on this silicon base, using optical techniques, they are they write a lot of transistor with a measure. They measure nanometers, and those transistors are the logical gates we have seen before in the functional components, and they build the logical gates, and the logical gates forms the functional parts of a computer. So inside here, we have the CPU. And remember, the CPU only has the arithmetic logic unit, the control unit, and the register, and that part, okay? Inside here, we don't have the memory, and we don't have secondary storage. It's only this part, the control unit, arithmetical logical unit, and the register. And some, depending on the chip architecture, you can have some more things here. We'll say it in a moment. But to improve the performance of modern chips, here they use a technique called the multi-core. And that means that inside that chip, we don't have a single CPU. We have more than a single CPU that share some components. So they can, the chip the chip can be executing more than one instruction at a time. So for example, if you have inside this chip 4 different CPUs, you can execute 4 things at the same time. So the performance almost is almost the quadruple of if you had a single CPU, more or less. Okay. So and another important thing here is the physical connectors of the chip. Here you have each model of CPU has different kind of connectors. In this case, the chip has little sockets here, and the motherboard, we will talk about the motherboard in a later video, has some connectors here, so that fits into the holes, and so the the motherboard can communicate with the chip. But it depends on the model. They are changing almost a year or 2 years. They change the number of pins here, the form of the chip, and whatever. So they are different chip providers that has different form factors, and so on. Now I want to take a look to a picture of a chip. This is the outside, the outside of a chip. I want to show you a picture of the insides of a chip. I have it here, and this is an Intel CPU. I don't know the model, and uh, those are the transistors. This is a photo. This is a real one. So you have here the cores. Each core has the CPU we were we have been talking about, and is able to execute instructions in parallel. Okay, here we have a queue. This is I don't know what it's used for in Intel architecture. We have here a shared memory controller. This is for accessing memory. Remember, the memory is not here in the CPU. So you need some logic to access the memory chips that are in another place. Here we have a system cache. There are different cache levels. For example, each core has usually a level 1 cache and a level 2 cache. Each one is bigger, but slower than the previous one. And the L3 cache usually shared between different cores. Remember that this is used for mitigating the von Neumann's bottleneck. We have the bottleneck accessing memory. So if we have if we don't access to the memory, but if we have the information here, we won't need to access the memory, and the CPU could execute the instruction faster. And we have here in Intel chips, this is a input-output controller. It's so quick that they have integrated it into the CPU, because if not, the communication with the CPU was slowing the connection. So in this case, it's an Intel CPU, and we have here other model. For example, I think this is an ARM model, and here you have much more cores. Here you have we have 4 cores. Uh, Today you can have it's usual to have 8 cores, maybe 16 cores in high performance Intel chips, but in different architectures. You have here, for example, I don't know, I haven't counted them, but there are 6. There are 24 here, maybe 10 here, 10 here, some more here, no? 4 and 4. So almost 44, 60, 50, 60, 60 cores. So those cores, maybe they are less powerful, but can execute more instruction in parallel. And it depends on the architecture. Each chip will have different instruction set. For example, this core, maybe they have less instructions than an Intel core. So it depends on the chip. Have some interfaces for accessing the outside, and that's a chip. And the most relevant characteristics, well, it depends. It's very complex to evaluate the performance of a chip, but the most usual providers are Intel, AMD today. Those are more or less the same. They share the architecture, and another one is ERM that is used in different computers. It was used before in mobile phones and low consumption devices, but now I think it's used for notebooks and some other computers. And depending, you need to read the characteristics of the chip. You need the speed, but the real speed of a CPU doesn't depend only on the chip's speed, because it depends on a lot of factors. But that's too complex, and I won't explain very much about that in this video. So that's how a chip is physically structured, and th this is what will be executing the code that you will be programming as web developers or mobile developers.